All right, let's do some calculations so that we can make the solutions that we want to make. So let's go down to part one. One way to make a solution is to make it from scratch, which means you add a specific amount of solute to water. Okay, so let's say I want you to make 100 milliliters of a 0.026 moles per liter solution of Kool-Aid, which is mostly citric acid. So that's what we're going to use for our molar mass of Kool-Aid. How much solute do we need to add to our flask? Well, we're going to need to multiply the molarity times how many liters we want, because liters times moles per liter will give us moles, which then we can convert to grams. So first step, I need to get my 100 milliliters into liters. So I'm going to divide by 1,000. So I want 0.1 liters of a 0.026 molar solution. Again, another way of writing that capital M is moles per liter, moles per 1 liter, in fact. So if I multiply, I'll find out that I need 0.0026 moles of citric acid. Okay, so I want 0.0026 moles of citric acid, but that's not very helpful because the scale is in grams. So I need to convert this into grams. Well, how much does 1 mole of C6H8O7 weigh? I've got to go to my periodic table and add this up. So there are 6 carbons, so 12.011 times 6. So let's do that. 12.011 times 6. That's 72.066. And then there's 8 hydrogens. So 1.008 times 8. That's 8.064. And oxygens, that's times 7. 16 times 7 is 112. Now I add these circled numbers together to get my molar mass. So 112 plus 72.066 plus 8.064. Answer, 192.13 grams. So now I multiply that by 0.0026, and my answer comes out to be 0.5 grams of C6H8O7. So now I get to actually make the solution, okay, which you'll do that part in class, where you'll add 0.5 grams of the solid to a volumetric flask, which has a line at exactly 100 milliliters. Okay, so you'll add in these little, it's 0.5 grams of this powder, and then you'll add water until it gets to that line. And then there you've done it. You've made your 0.026 molar solution. Okay. What if you've already got a solution that's 2 molar? How can you dilute that solution in order to make your desired concentration? So let's say you want to make 100 milliliters of a 1.0 molar solution, and you want to make 100 milliliters of a 0.20 molar Kool-Aid solution. There's a new equation. It's M1 times V1 equals M2 times V2. So you put in the concentration of your stock solution, which is 2 molar. We don't know how much we need. That's what we're going to solve for. You put in the concentration that you want and how much of it you want. It's okay to leave this one in milliliters. It just means your other volume will also be in milliliters. So divide both sides by the 2 molar to get V1 by itself. And then molarity is going to cancel out, and you'll be left with milliliters. So we've got 1 times 100 on the top divided by 2. That's 50 milliliters. How about if you want to make a 0.2 molar solution? Similar setup, it's still putting your concentration of your stock solution in for M1. M2 this time is 0.20 times 100 milliliters of it. Divide both sides by 2 molar again. Oops, I got the molar sign there. So basically here we're going to have 0.2 times 100. That's 20 divided by 2. So answer is 10 milliliters of stock solution. Okay, so what does that actually mean? Okay, so for this first one, you're going to fill it, essentially the 50 milliliters will be halfway with this stock. And then you're going to fill it the rest of the way with water. Okay, and then once it's all mixed together, you've got a solution that's not 1 molar anymore. It's not 2 molar, sorry, it's 1 molar. It's cut in half. Okay, and then for this second one here, if the volume is 10 milliliters that you need to add of the stock solution and then fill to the line with water, it's a lot less mixed in there. So it'll be a lot more dilute. And you'll see that when you make it. And if you're virtual only, there's also a video that you can watch of me making those solutions. So there you go. There's the math piece.